Good evening, everyone. Today, I would like to welcome all TEFian on behalf of TEF 2025 team on the 13th session of Technical Podcast. TEF Podcast to deliver technical insight in various fields that are valuable to our engineers to acquire technical knowledge. Today, we will discuss about the exciting topic that the evaluation of inspection in oil and gas industry, traditional to digitalization. Myself, Jaisil and Balu inspection engineer working in Kuwait Oil Company. And our guest speaker, engineer Balu Narayanan, senior inspection engineer working in Kuwait Oil Company. He is associated with TEF for more than 15 years and contributed as a committee member during the previous years. More than 25 years of experience in oil and gas industry on implementation of quality assurance and quality control framework in various phases such as occupational, construction, commissioning and in-service inspection. Welcome, Mr. Balu.
Thank you, Mr. Narayanan and the TEF 2025 team for giving this opportunity.
To go on to the topic, could you explain what inspection means in the oil and gas industry and why it is so critical?
Well, inspection, it is an integral part of quality assurance and quality control program established to identify the vulnerable factors that could compromise safety, integrity and operation. In the oil and gas industry, these vulnerabilities may be in the form of corrosion, erosion, cracks, voids, etc. This may escalate to catastrophic failures. So, a robust quality control program consists of not just inspections, but also include validated design, vigilant procurement control, established construction practices, testing and continuous monitoring. Among these all, inspection plays a vital role to ensure and reliable operation of the facility under demanding operating conditions. For this reason, inspection is critical and it is not just option. It is a mandate to ensure safe and sustainable operation.
Well said, sir. Next question. Which system or equipment usually require the most stringent inspection in oil and gas projects?
Yeah, stringent inspections essential for the equipments which are exposed to high pressure, high temperature and corrosive service conditions. Example, in the upstream facilities, wellhead and high pressure gas pipelines, crude storage and crude export facilities and pressure vessels in the booster stations. When coming to the refinery and the petrochemical plants, pressure vessels, exchangers, reactors in crude distillation unit, FCC, CCR units, amine handling facilities and sulfur handling facilities, which are exposed to aggressive process streams containing hydrogen sulfide, SO2, CO2, chlorides, acid, alkaline, etc. This can lead to corrosion and cracking mechanisms such as pitting, high temperature corrosion, hydrogen induced cracking, stress corrosion cracking. So these conditions is demanding stringent inspection program to prevent premature failure.
Well said, sir. From your experience, what were the traditional practice of material inspection techniques that are in common in past?
Yeah, especially for the inspections, it is broadly divided into two parts. One is destructive examinations and another is non-destructive examinations. Non-destructive examinations classified as visual testing, penetrant testing, magnetic particle inspection, radiography testing, ultrasonic testing and leak testing. Coming to the destructive testing, mechanical testing, chemical analysis and macro examinations. So these are the commonly used techniques across in our oil and gas industry.
Good, sir. Good. Very good. So the second topic is traditional practices and challenges. In that, so we have some questions to ask to you. Okay, the question is, can you elaborate in detail the applications of inspection techniques?
Well, as I told, the inspection techniques classified under destructive and non-destructive. Non-destructive testing is mostly widely used in the field. Generally, these techniques are applied to identify the surface defects and subsurface and volumetric defects. These surface examinations include visual and penetrant testing. For subsurface examinations, mostly we are using magnetic putty, but it is limited to ferrous materials only because of this limitation. For the volumetric analysis, mostly we are using radiography and ultrasonic testing. Other than that, destructive testing, mechanical tests to identify the mechanical properties of the material such as yield, tensile, elongation, hardness, impact testing, etc. For the chemical compositions, we are using laboratory analysis of the material to find the composition of the material. Apart from this, we are using in the pipelines gauge picking to identify the profile of the piping. It will identify the ovality and roundness generally, but it is not giving any thinning of materials. Going to the exchangers, the heater coils is examined by hydrotest inspections, and tanks in the in-service inspection is mostly used ultrasonic inspection to survey the material loss.
Good, sir. So, second question. So, what were the common limitations and the challenges of the traditional method?
As I told, these methods are mostly manual methods. There is no advanced technologies generally in the olden days. So the manual methods needs skilled people. So the human error is the most possible scenario in this method. And these methods are qualitative perspective only. So qualitative perspective, the interpretation will vary from person to person. So the results is not consistent across a person. And another big flaw in these methods is documentations, because these methods require physical documentation instead of soft copy documentation. So when comparing in big data, the traceability is time consuming. And in this method, there is a possibility of risk of mixing of material is possible, because the material procurement is purely realizing with the heat number traceability. During the handling or any course of the fabrication activity, the possible of erosion or any damage in the heat number will fail. It will leads to mix of materials. So this method resulted in delay, high cost, and high risk in some scenarios.
Very good, sir. Well said about the traditional practices and challenges what we faced. So now I am going to the next topic, and from the traditional method to digitalization, when we are come to the part. So just this is a transition to the modern digital inspection. So what kind of transition? So how it is happened, that we are going to discuss now. And so okay, the question is, what triggered the shift from manual checks to digital inspection system?
Yeah, of course. The limitation of the manual methods is really the key factor to shift from old practices to new era. As we faced many failures in the oil and gas industry across the globe, highlighted there is a gap in the inspection methods, and there's a safety concerns in some areas because of the hazardous environmental is involved. This method is difficult to deploy because of the human involvement, and the regularity requirements and the statutory body requirements also forced to adopt latest technologies. For example, high radiation sources are prohibited in some countries, which will lead to adopt alternative to radiography for the high thickness vessel. Global expansion of oil and gas facility across the globe demands more manpower. So at a certain time, the skilled people availability is demanding. So the advanced technology can only replace in the short period of time the skill. So these are the factors. And in addition to this, schedule and the cost optimization also influenced more. So as a general, these are all the factors is move the industry forward to the digitalization for safe and sustainable operation of.
Yeah, well said, sir. So I have the next question. So what are the key digital tools now used in the inspection?
Yes, there are many tools replace the earlier existing methods from the old practices. Visual inspections now aided with the drones and the thermal cameras for remote inspections. Ultrasonic testing replaced with automated UT techniques such as phased array ultrasonic testing, time of flight diffraction technique, TT techniques for the grit wells as well as high thickness pressure vessel wells. Long range UT. This is also automatic UT method to measure the pipeline integrity for more than 100 meters from one point access. Radiography technique is replaced with real-time radiography and profile radiography to measure the wall thinning of the piping and pipeline system. Gauge picking is replaced with the intelligent picking tools. It is in line with MFL and UT probes to measure the wall thinning also in the piping systems. Eddy testing is replacing the earlier method of hydro testing of heated tubes in the in-service inspections. MFL methods, negative flux leakage method, is used to identify survey of the tank bottom surface. Coming to the destructive examination, integration of the software with the earlier mechanical testing, that is universal testing machine, so we can get the real-time data of a stress strain curve to validate the mechanical properties. Honest test and the chemical analysis are replaced with the portable handheld equipments to measure at the field itself. And new technologies, new corrosions are identified with long-term exposure testing such as C and SSC are identified. These technologies provide quantitative and digital retrievable data, overcome the limitation of manual methods.
Good, sir. Well said. And you listed the digital tools. So now on another question. How has digitalization improved traceability and compliances?
Well, document control is now changed to the real-time data due to the digitalization. So digital adoptions changed the document access and the possible to review the location barrier. It is enhanced the turnaround review cycle also. Digital tools such as positive material identification program with the advancement of the spectrometers to allow on-site verification of materials to avoid the mix-up. So this will give the traceability for the asset life cycle time and ensure the supplier confirms verification and allow soft copy documentation for retrieval.
Good, sir. So another the next question. What role do standards play in driving digital adoption?
Standard bodies such as ASME, API, ISO as progressively endorsing the latest emerging technologies. For example, ASME Section 5 is adopting the automated UT techniques and it is defining the acceptance criteria. As well as ASME Section 8 also is accepting the alternative methods for radiography as well as UT. Coming to the pipeline wells, API 1104 standards giving the provision of automated UT in place of radiography. So such that many technologies are adopted by the controlling bodies, it will give the validity and the authenticity to the operator to adapt in their existing systems.
Good, sir. The next two questions. So can you share a success story where digital inspection improved project outcome?
Of course, there are many examples. I can point out one or two. In some of our export gas pipeline project, we have implemented mechanistic learning to enhance the production, and these wells are analyzed by automated UT using TOFD and the phase delay technique. So this ensures the safety hazard is eliminated by this technique. Also, the digital documentation of the UT, it will be validated for a life cycle time. The data in the recordable version can be analyzed and retrieved also possible due to the soft copy documentation. This will increase the quality and schedule to complete the project further in advance. And another example I want to note, the high pressure vessels which are manufactured in the shops more than 100 mm is really difficult to analyze using iridium 192 isotopes. So these Due to the latest technology of TT013, alternative radiography is emphasized and the project delivery is possible in short. So there are many examples we can quote. These are the two examples.
Those are well said related to the transition to modern inspection. Now the next topic we are going, future inspection methods. So I have some questions to answer, sir. So the question is one, how are the artificial intelligence and machine learning and IoT shaping the futures of oil and gas inspection?
Yes, now it is the time to change our existing method to adapting to the new technologies. As AI and machine learning are emerging, we can integrate the existing tools with AI and machine learning and IoT devices for future inspections. Presently, we are using online corrosion monitoring station with the corrosion probes and corrosion coupons. Presently, we are collecting the data through data logger. This can be integrated with the DCS and can be analyzed by the AI tool, and the results can be utilized by us for the predicting the chemical injection dosage and future inspection intervals. Also, AI-powered image recognition techniques may be utilized to automatically detect the imperfection in the radiography as well as in the ultrasonic testing, which will minimize the human error and enhance safety in critical application. IoT sensors embedded in critical assets such as pressure vessels, pipelines, rotating equipments enable the real-time data of pressure, temperature, and vibrations, helps to detect the early detection of deviations from operating norms. Machine learning models trained with inspection data and failure data can identify the degradation mechanism and trends to apply mitigation measures proactively. In overall, the future is data driven and also it is available at real time, will assist fast and accurate decision making.
Good, sir. So I have another question. This predictive inspection become the mainstream in oil and gas industry?
Absolutely, it's a possibility of predictive inspection in the mainstream income. Well, the predictive inspection integrated with AI, IoT, and machine learning will align with risk-based inspection philosophy instead of following calendar-based schedules. After the integration of these modern tools, the systems can trigger inspection requirement based on early indicators like thinning rate, vibration pattern, abnormal operating conditions. It will minimize unplanned shutdowns and optimizing the operational efficiency.
Well said, sir. And the next question. So what role does integration with the EPC, engineering, procurement and construction system plays?
Yeah, while we are going to these latest technologies, it's not only the in-service inspection data is not enough. We need to get the project data also to be integrated with the system. So for this, all the inspection workflows from the EPC stage also to be incorporated will play the vital role to ensure quality assurance across the asset life cycle. This integration enables seamless data and real-time feedback between QC personnel, project management, design, procurement, and suppliers, which will help to prevent non-conformities and reduce the cost.
Well said, sir. The next questions I have it. So how critical is cyber security and data integrity in the inspection system?
Yes. In the oil and gas industry, inspection data is safety critical. Means a compromised inspection report or altered corrosion monitoring record could lead to catastrophic failure, affecting lives, environmental, and operations. Operators, asset owners are hugely investing in cloud-based infrastructure, technology-enabled traceability, encrypted inspection data to ensure validity, and prevent tampering of data.
Good, sir. How does digital inspection enhance the global oil and gas supply chain?
Yes, considering the global supply chain, remote visual inspection via drone, smart glasses, and video conferencing enables the third party assess the supplier facilities in real time without the logistical burden of international travel. Digital tool enhance vendor approval in real time, the documentation review and decision making. It will help to maintain uniform inspection criteria regardless of manufacturing location.
Well said, sir. How the integrity is ensured for the non-accessible equipments and critical services?
Well, some of the equipments in service, it is not accessible due to its nature. Example, flat stack. Flat stack is operating at a high temperature and personal access is not possible. In that locations, we are using drones with camera for the remote access only based on the findings with the use of thermal cameras and other IoT sensors, which gives the data for predicting the shutdowns or any failures. In other areas like just pipelines, which is not able to identify the thickness by exposing the underground systems. In these systems, we are utilizing caliber picking with intelligent picking tools such as MF1 and UT props to identify the entire profile of the pipeline and thinning rate. So this will give the complete data to predict the minimum thickness of the material, and accordingly we can schedule the inspections. And if any thinning is more than our acceptable limit, de-rating is the only options for the as a temporary measures, and that section will be replaced in the near future.
So, well said, and you are given the brief explanation. And next, we would like to ask you the advice from you and advice and the closing of your thoughts. Sir, what competencies should the next generation of oil and gas inspection personnel should focus on?
Yes, due to the advanced technologies, it's a time to enhance ourselves. Deep knowledge in industrial codes such as API, ASME, ISO is essential and cannot be compromised. The inspection personnel must be conversant with the digital tools, whether it is a NDT data logging or cloud-based reporting or digital inspection checklist. With data becoming centric, they can able to interpret, evaluate, and make the decision from trends will become crucial. And the inspection personnel should enhance soft skills such as situational judgment, clear reporting, and adaptability to the situations are essential while they are doing remote audits.
Good, sir. And next, what is the best practice for companies beginning with the digital transformation in inspection?
To begin with digital transformation, digital traceability is not dead. From the conceptual stage until the plant in service, the data has to be integrated digital. Each equipment data such as design document, manufacturing document, service report should be digitally stored in the cloud-based storage system. This is not only solves document control and audit readiness, it also lays the foundation for protective maintenance, AI analysis for equipment lifecycle management.
Good, sir. Where is the inspection heading in the oil and gas industry over the next 10 years?
Yes, the future is moving towards a smart, interconnected inspection ecosystems with the help of AI, drones, machine learning, and digital twins. This will provide real-time visibility and ensure the asset integrity. Predictive maintenance backed by machine learning and IoT data will drive the inspection schedule. Remote inspection will become normal even for the offshore or hazardous environment. Ultimately, there will be a shift from current PDF document to dashboard review, which can deliver the real-time data instantly, not only to the inspection team, it will deliver to operations, maintenance, HSE teams for faster and safer decision making. I want to conclude with one திருக்குறள் அறிவுடைமை அதிகாரத்திலோடு எதிரதா காக்கும் அறிவினார்க்கு இல்லை அதிர வருவதோர் நோய். நமக்கு வர்ற ஒரு பெரிய டேஞ்சரையோ இல்லை ஒரு ஆபத்தையோ நம்ம முன்னாடியே அண்டர்ஸ்டாண்ட் பண்ணிட்டோம்னா அந்த ஆபத்து நம்மளுக்கு வரும்போது அதை நம்ம எதிர்கொள்ள தயாரா இருக்கிறதுனால நமக்கு எந்த ஒரு பாதிப்பும் வராது. Inspection is a save to the kind of thing. Inspection will give the advanced indications or informations to us to take the proactive measures. If you are following the indications and taking the proactive measures, the end danger will not come to at any stage. Based on this, we can eradicate the potential failure and ensure safety to environment, personnel and assets.
வெரி குட் சார். திருக்குறளோட நீங்கள் உங்களோட கன்க்ளூஷன் வந்து ரொம்ப தெளிவாக எல்லாருக்கும் புரிய வச்சுருக்கீங்க. தேங்க்யூ ஸோ மச். தேங்க்யூ சார். It is a very interesting and helpful program for our TT013 to acquire to get the insights on the subject knowledge on evaluation of inspection in oil and gas industries.
Thank you, Engineer Jayasilan and the TT013 team for giving this opportunity to deliver my insights. Your questions are really helped me to deliver my thoughts effectively. Thank you all.
On behalf of TEC 2025, I invite Mr. Periyasamy to honor with the memento to Mr. Balu Narayanan.